This is problem number 2 from section 3.1. In this problem it says find an equation for the tangent to the curve at the given point, then sketch the curve and the tangent together. So they want us to find the tangent line that is at this point, that touches this point for this line. And in order to find that tangent line, we need to find the slope first. So we're going to start by saying that the slope we're going to get, essentially, is going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. And then we're going to start plugging in x plus h into this formula here. So we're going to get limit as h approaches 0. Let's plug in x plus h, so we get negative 1 over 2 x plus h cubed minus the original function, which is just negative 1 over 2x cubed, and that's all over h. So that's going to equal, I'm probably going to want to find a common denominator here. So the first thing I'm going to do is I'm going to switch this sign to being a positive, and then I'm going to multiply this fraction by x cubed over x cubed, and this fraction by x plus h cubed over x plus h cubed. So it's going to look like this. I'm going to say x cubed over x cubed times negative 1 over 2x plus h cubed plus 1 over 2x cubed, and we're going to multiply this by x plus h cubed over x plus h cubed. And this is still all over h. And I forgot to write the limit, then we're just going to put a ditto right there, limit as h approaches 0. So equals ditto. When we multiply this, we get negative x cubed over 2, this will be x cubed, x plus h cubed, plus x plus h cubed on top over 2x cubed, x plus h cubed. Again, still all over h. And that's going to equal, let's combine these together. So you end up with negative x cubed plus x plus h cubed all over 2x cubed, x plus h cubed all over h. So because we're dividing by two things, we're dividing by 2x cubed, x plus h cubed, and by h, technically we can combine those denominators. The other way to think about it is you put this over 1, and then you flip and multiply it to the top because you have a fraction over a fraction. Either way, you're going to end up with negative x cubed plus x plus h cubed all over 2, and I'll call this 2 h x cubed x plus h cubed. Again, flip this and multiply it, or you can think about multiplying by 1 over h to this top fraction and multiplying this bottom one by 1 over h. I remember this is just 1. Okay, we need to evaluate x plus h cubed. So x plus h cubed is x plus h times x plus h times x plus h, which equals, this is going to be, when I do the first two terms, I know I get x squared, x times x times h, and then h times x, so I get plus 2xh, and then h times h is h squared. and that's times x plus h still. So I just did the first two terms there. Now we're going to get x squared times x, so that's going to be x cubed. X squared times h, so I get x squared h, right? This one times this one here. Now I come and do 2xh times x, that's going to be plus 2x squared h. 2xh times h is plus 2xh squared. H squared times x is plus h squared x, and h squared times h is h cubed. Combine those together and you get x cubed plus, there's 3 of these, so 3x squared h. There's 3 of these, so we end up with plus 3xh squared plus h cubed. We can now put this on top, so that's going to be negative x cubed plus x cubed plus 3x squared h plus 3xh squared plus h cubed. And that's all over 2h x cubed x plus h cubed. So now we're going to cancel the x cubes, and we end up with 3x squared h plus 3xh squared plus h cubed all over 2hx cubed x plus h cubed. And maybe I should have mentioned this earlier, but I mean our whole goal, because we have to plug in 0 for our limit, our whole goal is to get h canceled out of the denominator. I forgot to put some dittos on this, so I'm just going to put dittos with that limit. So equals, I'm going to factor in h out of the top, so it's h 3x squared plus 3xh plus h squared all over 2h x cubed x plus h cubed. We can cancel this h out, which was our goal. So now we have limit as h approaches 0 for 3x squared plus 3xh plus h squared all over 2x cubed x plus h cubed. Let's go ahead and plug in a 0. When I plug in a 0, this term is going to cancel, this term cancels, so I end up with 3x squared on top over, plug in 0 on the bottom, this will be 2x cubed, and then this will end up being, when I plug a 0 in there, x cubed as well, so times x cubed. So I end up with, when I reduce all this, this is 3x squared over 2x to the 6th, which reduces to 3 over 2x to the 4th. This is the expression for the slope for any point on this line, but they want us to find the slope at this point, so we want to say slope at 2 negative 1/16. That's going to be 3 over 2, and then we plug in a 2 to the 4th. So that's 3 over 2 to the 5th, which is 3 over 32, I believe. And so we can't reduce that, so 3 over 32 is the slope at this point. So now I need to find the tangent line. I'm going to say y equals 3 over 32x plus b. Plug in this coordinate, so I get negative 1/16 equals 3 over 32 times 2 plus b. This will give you negative 1/16 equals, the 2 and the 32 are going to cancel a little and give you 3 over 16 plus b. Subtract this over, you get negative 4 over 16 equals b. So we end up with, that'd be negative 1/4 for b. And so we end up with y equals, go ahead and write it right here, y equals 3 over 32 x minus 1/4. That's the tangent line. Now, they want us to sketch the curve. So if they want us to sketch this curve, we're going to go through and use our graphing calculator to do this. So let's go to y equals, and let's put in a fraction. We'll put a negative first. We'll put in 1 over 2x cubed. And then we'll put in our tangent line, which is, we'll go fraction 3 over 32 x minus 0.25. Go to window. Let's see if this will show up on the window. Let's graph it. And you can see how this, look at how this tangent line, the red is the tangent line, look how it touches the blue function at the point 2, negative 1/16. If we zoom in a little bit, let's zoom in right here. Yeah, this is a good picture of it. And look at it touch it right at that spot. It looks like it touches more than one spot, but trust me, it's only touching this one spot right there. Zoom in just a little tighter on it. This just comes back to the graphics of the calculator. But you can see we're basically touching at that 2 and negative 1/16 spot.